Hi everybody! Today we're going to be talking about scatterplots. So let's get started. Alright, so a scatterplot shows the relationship between two qualitative variables. So that could be like age and height, or um, hours slept and test scores, like we're going to look at, for example, later. So for this scatterplot here, a couple things for you to label. So the y-axis is going to be our dependent variable. This is also called the response variable. So this response variable or dependent variable depends on your x variable, which is called the explanatory or independent variable. Typically, if you're doing an experiment, that's the one that you're changing, and then you're measuring some response. And then when you have a scatter plot, each of these represents an individual measurement. So for this data here, I would say that it looks like it's trending upward. And if I want to do a line of best fit, you draw a line that goes through as like the middle of the data points. Okay. So correlation, which is the variable R, describes the strength and the direction of a scatter plot. So if R equals 0, there's no correlation at all. So that means that the data points would be random. There's no general trend up or down. There's just no relationship there. If R is a +1 or a -1, that's perfectly linear. So a +1 would mean that all of the dots are in a row, could be connected with a line, so that would be R equals 1. And R equals -1 just means that they're trending in a negative direction, also perfectly linear. If R is negative, that means that there's a negative slope. So it doesn't have to be perfectly linear, but just a general downward trend. And if R is positive, that means there's a positive slope, just generally trending upward. So you don't have to be able to understand like what a 0.3 correlation is by looking at it, but here's just a few pictures. 0.7, that means it's trending upward and generally a pretty strong, I'll say this would be a strong positive relationship. 0.3, that's more of a weak positive relationship. It's a general upward trend, but the data points are really spread out. And then this should actually have a negative in front of it. So a negative 0.7 and a negative 0.3, same sort of shape, they're just trending downward. So a regression line is the line of best fit, and the point is to minimize the distance to the line from all the data points. So like for this data, my line of best fit wouldn't go up here because all the data points are further away than this red line. So on your TI-84 calculator, or if you have a TI-84 app on your phone, you can do that there as well. Here are the steps to be able to find the regression line on a calculator. So I'm going to go ahead and pull up my calculator here. So from the home screen, you're going to press the Stat button and then press Enter on Edit. So don't have to move anywhere, just press Enter, and that will take you to your lists. You just type in your data in list 1 and list 2, your X data in list 1, and your Y data in list 2. If you want to clear out existing data, just go up to the top and press Clear. I'm not going to do that because I don't want to delete my data. And then if I want to find my line of best fit for these data points, press Stat again, go over to Calc, and then that fourth option stands for linear regression. So that means it's going to give you a linear equation based on your data. Press enter. X list and Y list should already be list 1 and list 2. If they're not, press the second button and then the stat button, and then you can pick which list you want to be your X and Y. So let me get back to that point. You don't need the frequency list or the store, whatever. Just go down to calculate and press enter. Y equals AX plus B. So in this equation, A is the slope of your line and B is your y-intercept. So for that last example, I'm going to have you guys go ahead and do this on your own. You're going to plot the data. Okay. Describe the scatter plot, strength and direction, and then use your calculator to find the equation. I'll go ahead and give you the equation that I got just so you can double check yourself. So when I plugged in those values, I got my slope as 6.46 times x plus 34.9. So go ahead and make sure you can get that same answer, but I want to give you that so you can check your work. And see y'all tomorrow.